Jadi mana? Oh,
Okay, Bismillahirrahmanirrahim. Assalamualaikum and good afternoon. Okay, can you guys hear me?
Yes, madam.
Yes, madam.
Alright. Okay. I will do recording through my laptop. Okay. So for today's class, once we finish, I will upload in my YouTube. Okay. So please take notes. You guys no need to record in the Teams. Alright. Okay, so to start for today's lecture, right, so I will do a recap. Okay, so we have done the sequential structure. Okay, then we have done decision making. Such as the if, structure, and switch. Okay, so for today we are going to see this repetition. Okay, mainly we call this as a loop structure. Alright. Okay, so there are three types of structure that you are going to learn today. So by the end of this lecture, we are expecting students to explain the purpose of the repetition structure and do comparison between the while loop, do while loop, and for loop. Right? Okay, so let's begin with what is the meaning of repetition structure. Okay, so repetition structure, or in very simple words, we call it as a loop that executes a block of statements. Okay, we call it as block of statements. Why we call that as block? Because there is a task that need to be performed um, multiple times. Okay, until a condition is met. So this condition you need to find out in the problem. What is the suitable condition that need to be stated, right? Okay, so what is the reason that this loop, or what is the useful of this loop? Okay, so using this loop structure, we can avoid repeating code manually. Okay, so let's say you want to display the statement, okay, repeatedly many times, let's say 10 times. Okay, so using maybe system out print in, something like that. Okay, so you want that output to be displayed 10 times. So if we do coding for 10 lines for the same coding, we repeat that for 10 lines. Basically it is not a systematic way. Okay, so we can do it much simpler methods, such as we just have that kinds of one task, but then we use loop structure so that the task is being performed repeatedly many. Okay, so that is the useful of using these loops. Alright, so to avoid repeating the code, okay, manually, and then you can have programs or the coding shorter and clearer. Shorter means instead doing the coding manually for 10 times, so you can make it shorter to maybe 2 lines only. Alright, 2 lines of coding. Okay, then you can do other tasks, not only to display. You can perform any computation, such as do some counting, or do summations, or do other operations related to arithmetic, and maybe we want the program to read the inputs for several times, so you can do some automations in the program. Alright, so for this loop structure, there are three types. Okay, while loop, then we have do while loop, and then for loops. Okay, so between these three, the most powerful one is the for loop. Okay, why for loop? Because it is more systematic way, where some conditions you can combine, and then it has many applications. Okay, such as in array form. So usually we use or apply for loop. Right? Okay, so let's begin with the loop itself. Alright, so this is by general general definitions in the loop. Okay, basic knowledge that you need to know about the loop. Okay, so any types of loop, either while, do while, or for loop. Okay, the loop itself has three parts. Right, first one is the initializations. Initialization, it means that your variable must have starting value. Okay, why these initializations need to be used? Okay, because in your loop, your iterations need to be counted. Alright, so that kinds of variable that used in the loop must has initial value, because the tasks that need to be performed need to be counted. Okay, so it refers to some kinds of discrete value. Okay, it involves numbers. It involves numbers, so that the loop is working. Alright, so to make sure that the loop is working, your variable that involved in the iterations need to be initialized. Alright, so what is the initialization's value? It can start with 0, it can start with 1. Okay, so how do we set these initializations value? Depends on the program, okay, or depends on the problem, whether the loop is based on increasing value, incremental, or depends on the decremental. Alright, So this is initializations. Alright. Okay, next is the conditions or tasks. Okay, conditions or tasks. So the purpose of setting these conditions or apply the task is to make sure that your loop should be continue or stop. Alright, it's something like the functions is similar to if structure, okay, or switch structure. So if you want to make sure that the task should be ended, so we apply the break, for example. Okay, for instance, we have in the switch structure, we apply the break. And then in this loop, so we depends on this task or the conditions value. Alright, next one, you must have the update. You have to update based on the loop based on the incremental value or decremental. Incremental means you have start with small number initializations, maybe 1. Alright, and when you want to update the value, okay, so we said that maybe the maximums reach stop at 10. Alright, and then you have some incremental value increase by 1, for example. So we use I plus plus. Alright, so this is example incremental. If decremental means that you start with big number, maybe 5, okay, and then it stop at 1. Okay, so you have decremental value I minus minus. Okay, so this is another situations. Alright, so that is the purpose of doing updates based on incremental or decremental. Alright. Okay, so the loop for this flow diagram will have start, initialize, check the conditions. Then if it's true, then we have to execute the body in the loop structure, updates, and check what is the next conditions. And then if it's false, then the structure must exit. Alright, and then going to the end process. Okay. Alright, so far any question?
No, madam.
No question, madam.
No, madam. No question.
Sekejap ya. Okay, now we'll see the first types of loop. We call it as the while loop. Okay, so this while loop repeat as long as the condition is true. Okay. Okay, so the process in the while loop, the condition means like they are checking the values in the loop. Okay, condition check first, then the loop will be execute 0 times if the conditions is false. Okay, the loop will execute 0 times if condition is false. And this while loop is good if you have unknown number of repetitions. Okay, unknown number of repetitions. And the one that is in this box is the basic structure for while loop. Okay, so we have while, the codings in the Java, we have while, then followed by this parenthesis. Okay, so inside this parenthesis is your limits. You can have maybe I greater than 10, right? Or you can have I less than 5, okay, and so on. Okay, so for this kinds of while loop, you must have initializations lah before. Okay, what is your I value, something like that, to start begins, and this the statement inside here is the task. Maybe the task referring to this statement is to display, or maybe to read the inputs for many times, or maybe to compute something. Okay, so generally we call it as the statement. So what types of the task depends on the program. Alright, and the structure for while loop is similar to if structure. For any kinds of structure, like if you're having if structure, if conditions, first one we have parenthesis, correct, and then second one we have maybe else if, another conditions, right? So for if conditions, you must have one set of open and close bracket. Okay, open and close brackets, and so on, right? So same thing with this while condition. Okay, so let's see example for this while loop. Alright. Okay, we have the task is to display numbers from 1 to 5. Let's identify. Okay, 1 to 5. These kinds of problem having incremental or decremental process. Incremental or decremental? That's my questions.
Incremental.
Okay,
Incremental.
increasing, right? 1 to 5 is increasing, correct? Okay, so let's say we have the while loop, while loop. So based on previous slide, we have basic structure for while. Okay, so we have while, then we have these kinds of parentheses, alright, and the task is to display, correct? So this is the task, to display the numbers, alright. So in the while loop, we have the task that is based on the coding, probably system.out.printin. So inside here is your value of I. It's not displaying based on the double quotes. Alright, the one with the double quote is to display the statement. Alright, specific statements. Alright, okay, so in this case, because we want to display that kinds of number, so the number is your I value. Okay, so I will just call this I. So why we call it as because this is a loop. So when this loop need to work, right, so usually it relates to the iterations. So usually I symbol is used, so this I means iterations. Okay, usually. So sometimes when you have the number that you want to display for many times, so we code it as I. Can you use other symbol for this variable I? Yes, you can. Okay, you can use other symbols like just A, you can use X. Okay, but you need to know when you want to do that statement, so what types of variable that involved in the statements. Alright, so in this case we want to display this I. Alright, okay, so we want the number display start from 1. Okay, so in this while loop, this 1 is the initial value. Okay, initial value. So 1 is an integer, correct? That's a number. So we declare that integer I equal to 1. So I equal to 1, this is your initializations. Okay, initializations. Alright, you must have initialized. Why you must have initialized? Because this loop is counted, okay, for numeric types. Okay, for numeric, based on numerical times. So it must has initializations for the task, so that the task can be started and there must be a stops. Right. Okay, next one, we found the limits. Okay, so this is the starting value 1. This is the upper limits. When it needs to stop? When your I reach at 5. Okay, so it means that we are going to display the numbers 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, because this I is integer, right? I is in integer. Okay, so for this number, start from 1, going to the next number, actually it is increased by 1. Alright? Next, after 2, increase by 1 also. Then reach at 3. Okay? So, all of these I value need to be displayed. Okay? So, the coding to display, the statement is system.out.printin. Alright? Then, the iterations need to be increased. So, what types of the increment value? Increase by 1. Okay? So, you have learned these kinds of incremental value, right? I plus plus mean I plus plus mean I increase
That's one into initial value.
increase by 1. Okay, I plus 1 lah. Alright, that's the incremental value. Okay, so initialization, then we put the maximum limit. We know this is increasing value, right? Your loop structure is based on incremental. So this limit we call maximum limit or upper limit. Okay, the value is I less than and equal to 5. Okay, so we include equal because we must display 5, right? Okay, so now what types of conditions that you can change instead using I less than and equal to 5? Can we change these conditions to other form? Can we change that? Can we change?
Greater than or equal to 5?
I'm asking about other form. Instead using I less than equal to 5, can we change this to other form? Can we change this to other conditions?
Yes.
What's that?
I less
Less or equal than 5 or greater than or
Hmm.
less than.
No, soalan saya, sorry ya, Kwazi and I have to speak bahasa Melayu. Okay, soalan saya adalah boleh tak tukar I less than equal to 5, okay, to another condition. Okay, tukar kepada condition yang lain. So that's my question. Can we change this I less than equal to 5 to other condition?
tak. Can madam?
Okay, those yang answer can, what's that? What is the condition?
Less than 6.
Okay, I less
I
than
less
6.
than 6.
Alright, okay, boleh juga. This one also can, right? Because this limit less than 5, what is the integer? Less than 5? Integer that
3, 4,
less
5.
than integer I is
4.
integer, cannot have decimal number. So what is the integer I less than 6? What is the maximum integer?
5.
5. Maximum is I5, right? Maximum. Okay? So, you can use I less than and equal to 5, or you can use I less than 6. Alright? Which one to be used? Depends on you. You want to use the one include equal, or you want to exclude the equal. Alright? There's no problem in this case. Clear? Are you clear with that?
Yeah.
Alright? So clear? So, the structure just now, it must have initialization. Okay, so we initialize I equal to 1. Then you have while structure. Then you put the condition. Alright, then you have the task. Then you have, in this case, because this is increasing, so we put incremental value. Okay, so these conditions, there's no unique method for you to define the conditions here. It depends on the problem. As long as you meet the objective, which is to display the numbers from 1 to 5. Alright? Okay? Okay, I have another questions. I plus plus, can we replace with these kinds of symbol? I equal to I plus 1.
Can.
Can, okay? It's the same meaning, correct? I plus plus is I equal to I plus 1. Can we use I plus equal to 1 to replace I plus plus?
Can.
Can we replace that? Can we replace I plus plus to I plus equal to 1?
Yes.
No.
Why no?
Yes.
Basically,
Yes.
yes, you can use that because it has same meaning. Alright? For I, sorry. Okay. I plus plus, you can change that to I equal to I plus 1. Or, basically you can combine like this, I plus equal to 1. So, these three have same meanings. Increase by 1. This is the meaning. Alright? So, you can use either ones. Okay? The popular method is I plus plus. Okay, next we goes to the second conditions. Do while loop. Alright. So, if compare with while loop, this second loop runs the body first, then check the conditions. Okay? If while loop, we check the conditions first. The structure check the condition first. In this second structure, do while, the task is do first. The statement is being performed first, then the condition is being checked later on. Right? So this do while loop is a bit different because it executes the statement at least one, and then the condition check after that. And usually this do while loop is applied for menu programs or item driven programs. Alright. The structure for this do while, okay, we have these kinds of do, and we have the task, the statement, right? Then close the structure, and the conditions is later on written as while conditions. While conditions, so this is your conditions lah, whether it has upper limits or lower limit. Alright. Okay, then as usual you must have initializations lah before these two. Alright. Okay, in this do while, it is a bit unique and a bit different, right? If in the while structure, there's no semicolon here, there's no semicolon. But in the do while, okay, do while, there must be a semicolon. Alright. Okay, so let's see this example. Ask user to enter a number until they enter 0. Okay, ask user to enter a number means that the user need to enter the input. Your input is a number until they enter 0. So the user need to enter the numbers many times until the user enter the number 0. Alright. Okay, so let's define that the number which is your input as integer. Okay, so you have a programs before declaring that request the user to enter the inputs, right? So all the import library file for the scanner should be used lah. Here I just highlight at the main part. Okay, so then the input we define as the num, alright, integer num. Okay, so because this programs needs to read the program. Okay, we have the coding which is the task to read the input as follow. Okay, as follow. Okay, your variable num, okay, is equal to input dot next integer. Okay, this is the functions to read the input. Okay, so I think you're familiar with these codes. So the input is stored as num, the variable name as the num. So basically the program will do this task at first time. Okay, after that checking. So when the user, let's say the first number is 5, okay, so then the program will display this, will read this number 5. Okay, will read this number 5 and then later on check the conditions. Alright, the number here is not equal to 0, so the process will be repeated going like that. Okay, repeats. Then what is the next input that is entered by the user? Maybe let's say it's 11 for second times, so the program will read the inputs. Okay, then we have 11s, then check the conditions. So it is 11, it is not equal to 0. Okay, so the process will repeat. Okay, will be repeated. Next, let's say the input is 0 this time. Okay, so this input 0, because it is 0, so the program will be stop. Okay, stop because this condition is met. Okay, so basically this kinds of loop always run one times at least, but here how many for 5, 11 and 0 that this loop runs? How many time? 5, 11 and 0. Let's say the input is 5, 11 and 0. So the loop is runs for how many times in this case?
3.
3. Alright? 3, yeah? This case, this is first time, second time, and third time. Alright? Okay. So that is the explanations. Okay, now we see the third loop, which is for loop. Okay, so this for loop is used when number of repetition is known. Okay, so you can combine the conditions in one line. So generally for loops, you have for followed by the parenthesis. Okay, followed by the parenthesis. So inside the parenthesis, there are 3 parts. Okay, the first part contain your initializations for your variable. Second one is the condition, either upper limit or lower limit, and then updates value. So update value can be based on decremental or incremental, right? So everything is combined lah. So it is much simpler compared to previous two structures. Okay. So in order to use this for loop, you need to know how many iterations that involve, okay, in this for loop. Alright, so let's see. We have the problem which is to display numbers 10 to 1. Okay, so we are trying this using for loop. Okay, using for loop. Okay, so let's identify. Okay, so start from 10. So we want to display this number 10 and stop at 1. Okay, 10 to 1. So the task is to display. Alright, so this is the statement involve display. Alright, okay, so for using for loops, for loop, let's define that this as x. Okay, this is as x. So your x start from 0. Okay, start from 0. Start from 0. Your x start from 10. Okay, x here from 10, and it should stop at 1. Start from big number, stop at small number. Okay, so what is the process involved? Increasing or decreasing?
Decreasing.
Okay, decreasing. Start from 10 and stop at 1. Decreasing. So you have identified there is a decremental involved, right? Okay, so this x variable, this is initial value because we want to display start from 10, and this is a stopping value. It should reach at 1. Okay, so there's a decremental value. Okay, decremental value. So we use because we define the inputs, the variable as x, so there must be x minus minus. Okay, so we start with initialization. Okay, then followed by your limits. Okay, in between, the middle one is the limit, and your process either increasing or decreasing, right? So between these three, it must be separated using semicolon. Alright, between these three. Okay, between these three. Okay. So we initialize x as 10. There is the initialization's value. Then because that this is decremental, decreasing, the process is decreasing, so it must have lower limit. Okay, so just now you have increasing value for previous while loop example, right? Using I plus plus. So you start with small number 1 and stop at 5, for example. Okay, so in this case we are going to use the iterations based on I plus plus. Okay, increasing. Okay, so if you have this increasing value, so you start with small number, stop at the larger number, big number. Okay, so for these kinds of incremental, you must have upper limit. Use upper limits. Upper limit referring to your maximum value for that kinds of structure. So if you start with big number, okay, going to the small number, so you are going to use decreasing value or decremental operator, and you must use lower limit. Okay, lower limit. Okay, upper limits will be denoted something using this kinds of symbol, or maybe here you have to choose which one that you want to use, less than or less than and equal. If it lower limits, you must use this kinds of symbol, greater than or greater than and equal. Alright. Okay, so going back to this example for loop, we start with big number which is 10, so it will reach at 1. Okay, so your x here defined as integer. Okay, so it cannot be as floating number, as integer. So we are going to use lower limits. Okay, lower limit means that what is the smallest number for that kinds of number to be stopped. Alright. Okay, so in this case we use x greater than and equal to 1, and then since we have identified this is decremental, so we use x minus minus. X minus minus, it's equal to x minus 1. Okay, means that it is decreased by 1. X equal to x minus 1. Alright, so instead using x minus minus, you can coded it as follow: x equal to x minus 1. Alright, you can code also x minus equal to 1. Okay, also decrease by 1. But x minus minus is much simpler form. Alright, okay, is there any other conditions that we can change for this limit, the middle one? Can we change the conditions? Can we change the conditions x greater than and equal to 1?
Can.
Can.
Okay, what's that? What is the condition?
X greater than or equal to 2.
Why 2? If it's 2, then it will not reach at 1. You must reach 1.
X
X
greater than
more
0.
than 0.
Okay, so x greater than 0. Okay, because your x is integer, alright? Okay, your x is integer, so basically you have 10, 9, 8, 7, right? So x greater than 0, so this part will be reached at 1 also. Okay, because 1 is greater than 0. 1 is greater than 0. So instead using x greater than and equal to 1, you can use x greater than 0. Right? So you can design with another conditions lah, but it must refer to lower limit. Alright. So when you want to design any types of loop, you have to make sure that your iterations is something that countable. Okay, so it means that you must have closed region. Closed region means that, okay, let's say you have conditions x. Maybe here you start from 10 kan. Let's say your x is 10. Then you set, let's say, x equal to 1. Let's say then you have decreasing value x minus minus. Okay. Okay, I want to code this as as scale numbers. Okay, so you start from small number, correct? Right? Okay, basically 10 is something like here. So then I have 1 here, something here, correct? So minus minus means that you start from this 10, then you're going to the left. Okay, from big number to the small number. Now we check the conditions here, because your x start from 10. Now where is the conditions going to? X less than 10. So where is the conditions x less than 10? So basically it's going here. Okay, going here. So it's separated by these kinds of lines. So basically your region is not bounded. It is open region, no limits if you compare. Alright, because it's supposedly to be decreased, right, from 10 going to 9. Okay, let's say 9 is here. Alright, then going to 8. Okay, if you use x less than 10, basically your scale numbers or region here is open. Open means that there is no limits for these numbers to be stopped. Alright, okay, so there will be an issue here if you use these kinds of x less than 1, because this is based on decremental process. Alright, so for this loop, the hint is you need to know what is the counting numbers. Then you must have, when you want to design initializations, limit, and incremental or decremental operator, it must be bounded region. Okay, bounded region means that your scale in this iteration should have a limit, should be stopped. Alright, okay, any questions for this part? No questions? Okay, so to summarize between those three, so for while loops, the condition check before loops. Okay, is it the task or the statement execute at least once? No. For do while loop, the condition check after the loop. So the execute will the task or the statement will execute at least one. Okay, for for loops, the condition check before loops. Okay, because your tree condition is stated next after the for loops in the parenthesis and then followed by the statement. Alright. Okay, so this is the summary. Okay, so as I mentioned just now, when you have open regions or open limits for your conditions, okay, it will go into this infinite loop starts. Alright. So infinite loops occurs when condition never becomes false. So there's no stopping criteria in your loops. Okay. And in your any of your loop structure, if you did not put the incremental or decremental value, your loop also will be infinitely many. Okay, that to be performed. The task might be displayed for many times because you did not status the incremental or decremental operator. Alright, so we want to avoid these infinite loops. Okay, so when you run the programs, probably the program will ask you to enter the inputs, or maybe there's no limits after that. The program still running. Okay, you can see that program will not stop. Okay, one of the applications for any types of the loop is loop with the accumulator. Accumulator means that there is a carry value for the task. Okay, we call it as the accumulator. Okay, for example, here we have programmed some numbers from 1 to 5. Okay, so let's say we have the variable sum. Okay, and then we put initializations. Right, initialize, because there is a computations involved in this problem. Alright, so we call sum. So we want to get the value. For example, sum first one, 1 plus 2. Okay, the first number is 1, so we want to add, and then we want to add with plus 3, plus 4, plus 5. So manually, this is manual calculations lah for this sum. Alright, so you can do this task to compute the sum in the iterations using the loops. Okay, so if we want to try with this for loop, so you need to set the initializations. Alright, this is the first number, that it should stop here. Okay, it should stop here. So this one, let's say we define the variable name as I. Sum is your final variable that you want to compute. Okay, so basically this manual calculations involve additions of the numbers. Okay, so it must has initializations value. Okay, operations that involve additions operator, the initializations must be 0. Okay, must be 0. Involve additions operator. So this sum must has initial value. Okay, initial value which is 0. If this operation is to do some multiplications value, let's say you have multiply, you want to check the multiplications, so we call this multiply, the variable name. So you want to check 1 times 2 times 3 times 4 times 5. Okay, so in this case, your multiply, you must have initial value as 1. Okay, this is initial value. Cannot assign initial value for multiply as 0, because if you have 0, then when you multiply with other numbers, the product will be 0. Alright, so this is general knowledge that you need to know if your problem, okay, if your problem involve operators or arithmetic operators related to additions or multiplication. Okay, because the loop involve initialization. So if your program involve any arithmetic operators, and for the purpose of accumulator, okay, there is an accumulations process involved in the computations, so you need to set suitable initializations value. If your operations involve additions, the example computes the summations or the total for some variable, then that variable need to has initializations of 0. If involve multiplications, then your variable need to be initialized as 1. Right, so this is general knowledge for the students need to know. Okay, so going back to this, because if you want to use for loop, so first one we start with the initialization. let's call that here we have the numbers 1 to 5, so we use name as I. Alright, so start with 1. Okay, start with 1, so this is a stopping. 1 to 5 involve incremental or decremental? 1 to 5, incremental or decremental?
Incremental.
Okay,
Incremental.
so we have incremental process. So using I++. Alright, so start from 1. So what types of limit, upper limits or lower limit that need to be used? Upper limit or lower limit?
Upper limit.
Upper limit.
Upper limits. Okay, what is the maximum? Which is 5. Okay, so we use upper limits. Upper limit, so you need to set whether you want to include equal or not. Okay, so here if we put equal, so we have I less than and equal to 5. Okay, is it having that? These conditions you can use I less than 6. Correct? Can we use I less than 6?
Yes.
Right, same things. Same result, even we use different conditions. And then this is the formula, sum plus equal to I. So this is a shorter formula. It has the same meaning, something like sum equal to sum plus I. Alright, so here your sum, this sum, basically it has initial value 0. Okay, what is your first I? 0 plus 1. First I is 1. Okay, sum here is 0 because it has initialized before this as 0, and your loop can be counted. Okay, so the first iterations involve 0 plus 1, so your first value of sum is 1. Alright, then the task will be performed until the conditions is met, the final one, which is until the upper limits. Okay, the last I is 5. Alright, then the process will be stopped. Alright, okay, what is the final value that will be displayed here? Here we have system out print in outside of the loop structure. Outside, it's not inside. So what is the output for this? Total. What is the output for this total? What is the output?
15.
Why you think 15? 15? Any the value that 15? Any other value? Not 15. 15 or
5.
not 15? Are you agree total is 5? Are you agree with total 15? Are you agree with this?
Yes.
Alright, Quasi said yes. Okay, so output is total 15. Alright. Okay, now we have also nested loops. Okay, either any types of loop here, while loop or do while loop or maybe for loop, you can have or design nested loop. So it's similar to your nested if, right? You can have nested loop here. So nested loop means a loop inside another loop. Alright, for example, let's say we want to display these kinds of patterns. Okay, so basically the symbol can be defined by the row and column. Okay, row and column. So the output or the symbol display here, it has how many rows? 1, 2, 3, 4. 4 rows, Yeah, 4 rows. And the column 1, 2, 3, 4. 4 columns. You can display that. Alright, so we can design the first for loop, which is outer for your row, followed by your column. So basically the task will be displayed based on the conditions. Alright. Alright, so the first outer 4 is for your row, then the first outer, the inner one is for your column. The task is to display these kinds of symbol. So basically, these things will be displayed using system.out.print and just display these kinds of symbol in this line only one times. Alright? Okay, so then because the symbol is displaying from one symbol and increasingly many, so basically your structure is based on incremental value. Alright? So this is another example using nested loop. Okay, we have just small discussions. Let's see the first program. Okay, let's discuss this in 5 minutes. We almost reached the time. Okay, can see the slide now. First one, which loop should be used? For the first one, which loop should be used?
While.
Is it while loop? Okay, how about the students?
For.
Okay, read first. Is it while or not?
Do what?
Do while.
While.
Hmm. You agree with that? You agree with that? Okay, you read first,
Don't know, madam.
Okay, let's see question number 2, number 3. Check for question number 2 and 3, yeah? One, two, three. Wait,